Hello everyone, my name is Muhammad Adib Bin Halizam, and today I will be presenting the prototype design pattern. The content of this presentation are intent, motivation, structure, consequences, known users, and example and demo. For the intent, prototype is a creational pattern that lets us copy existing objects without making our code dependent on their classes. It allows new object to be created by duplicating or cloning an existing object rather than create a new instance from the scratch, something that may include costly operations. The existing object acts as a prototype and contains the state of the object. The properties of the newly copied object may be changed only when necessary. This approach saves time and expensive resource, particularly when creating object is a complex process. For the motivation, in programming, there are situations where we need to create objects that are almost identical to existing ones. It can be inefficient to create these objects from scratch using their respective classes and constructors, particularly if the objects are complicated or the construction process is costly. Consider a situation in which we are developing a graphic editor. For instance, we can draw shapes like squares, circles, and lines in this editor. If a user draws a blue circle and then wants to draw 10 more of the exact same circles in different colors, it would be cumbersome to set all the properties, such as size, border, and positions, for each new circle individually. Here is where the prototype pattern comes into play. It simplifies the creation of new objects that should be like existing ones by allowing us to copy or clone the existing objects. This way, we avoid the overhead associated with new instantiation when an object's initial configuration is similar. To sum up, the prototype pattern allows us to simply clone an instance of an object and make modifications to it rather than having to create each instance from the ground up when we wish to produce additional copies of the same object set in a certain way. In essence, it creates objects with a great degree of flexibility while saving time and resources. For the structure of the design pattern, the participants consist of client, prototype, and concrete prototype. The client is responsible for creating a new instance by asking a prototype to clone itself. The prototype, which is an interface or an abstract class, describes the interface for cloning itself. It is often implemented by adding a clone method to the objects which need to be cloned. And next one is the concrete prototype, which are classes that implement the prototype interface or inherit from an abstract class where the clone method is defined. These classes define the copying behavior and typically use a language-specific cloning mechanism to create a copy of the instance. This is the UML class diagram for the prototype design pattern, which consists of the client class and a prototype class, which is an interface or an abstract class and has a clone method, and a concrete prototype class which implement the interface and it has a clone method and a concrete prototype which is the constructor. There are several pros of this design pattern. The first one is abstraction. Prototypes hides the concrete product classes from the client, thereby reducing the number of names clients know about. This pattern lets a client work with application-specific classes without modification. Next one is adding and removing products at runtime. Prototypes let us incorporate a new concrete product class into a system simply by registering a prototypical instance with the client. The next one is added consistency. All objects derived from the same prototype are assured to start in the same state by using the prototype pattern to ensure that objects are created consistently as clones of a prototype. Errors related to the ad hoc item generation are decreased by this standardization. The next one is fewer subclass. In situations where class hierarchies might become excessively deep due to the necessity of introducing numerous new classes, the prototype pattern helps by cloning a single instance set up with the desired configuration. It avoids the need to subclass in order to create objects with particular states. There are also drawbacks for this design pattern. The first one is complicated cloning. When the prototype pattern is implemented, each subclass must implement the cloning operation. This can become complex if the objects have circular references or if the copying process is more than just a shallow copy. Therefore, the implementation of the prototype can become a point of complication. The next one is deep versus shallow copy. The default cloning mechanism in many programming languages is a shallow copy, which might not be enough if the object contains references to other objects. A deep copy might be necessary, which involves recursively copying all object graphs. Making the right decision between shallow and deep copies can be non-trivial and a potential source of bugs if not handled carefully. There are several known uses for the prototype design pattern. The first one is graphic editors. A graphic editor might use the prototype pattern to clone complex graphic objects like shapes or layers without recreating them from scratch. This can greatly reduce memory usage and enhance performance. The second one is gaming. Characters and objects in video games frequently begin in the same starting states or actions before evolving in diverse ways. Prototypes can be used to instantiate new game characters efficiently with predefined configurations. And the next one is object serialization. When developing an object serialization and deserialization process, the prototype pattern can be useful. When an object is deserialized, it can be restored to its initial state by storing and cloning its prototype. For the code example and demo, I have developed a movie maker to demonstrate the prototype pattern. This is the class diagram for the movie maker, which consists of client, prototype interface, and movie. The client consists of methods which are create movie, clone movie, print movie details, change movie title, change movie director, and change movie category. The prototype interface consists of clone method, and the movie class consists of title, director, and category, which are all private string, and consists of methods which are movie, the constructor, the clone method, the get title, get director, get category, and toString methods. This is the implementation of the prototype interface, which consists of the clone method. This is the implementation of the movie class, which is a concrete prototype. It consists of several attributes and the constructor and getter and setter method, and consists of the clone method and also the toString method. And this is the implementation of the client class, which will create a new movie, clone an existing movie, print out the detail of a movie, change the title of the movie, change the director of the movie, and change the category of the movie. And this is the implementation of the main for the prototype pattern demo, which will create a new movie, clone it, and print necessary details to show the comparison between the original and the clone objects.
Okay, so this is the code for the prototype design pattern example. This is the prototype interface, which has the clone method. And then this is the concrete prototype, which is the class movie that implements the prototype interface. It has three private attributes, which are title, director, and category. All of them are string. And the constructor of this class set the title, director, and the category. And each of the attribute also has getter and setter method, which are get title, set director, get category, and set category. It also has a clone method, which is overridden from the prototype interface. It will return new movie with the title, director, and category. And it also has a toString method, which will return a string of the movie details. The next one is the client class. It has several methods. The first one is to create a new movie. And the next one is to clone an existing movie through the clone method in the movie class. And next one is to print out the detail of a movie. Next one is to change the title of the movie. Next one is to change the director of the movie. Next one is to change the category of the movie. The next one is the prototype pattern demo class, which has the main method. In the main method, we declare a movie client object of a movie client, which is a client object. And then we create a new movie called The Matrix. And the director is Lana Wachowski and Lily Wachowski. And the category is sci-fi. And then before cloning the original movie, we print out the original movie details, and then we clone the original movie through the clone movie method. After cloning it, we print out both the original and clone movie details to see the comparison, and then we update the title and category of the clone movie to the Matrix Reloaded, and the category is sci-fi and action. After updating the clone, we print out the detail for both original and clone to see the comparison between the two movie details. Let's see the output of this program. Okay, this is the output. Before cloning, it only has the original movie with details of title The Matrix, the director, and the category is sci-fi. After cloning, we have two movie, which is the original and the clone movie. Both of them has the exact same details. You can see it here. And after updating the clone movie, we can see that the clone movie detail has been changed, which is the title from The Matrix become The Matrix Reloaded, and from category sci-fi changed to sci-fi and action. And only the clone movie detail is affected. The original remain the same. You can see it here. Right, that's all for the code.
And last but not least, these are the references that I use for this presentation, which are the Book of Design Patterns, Element of Reusable Object-Oriented Software, and the Git4Git website, diagram.net, which I used to draw the class diagram, and the prototype article from Refactoring Guru website. And the last one is the template for this presentation, which I get from the Slide Mania. That's all from me. Thank you.